Okay. Very first question, it says solve the triangle, correct?
Yeah.
Solve the triangle below. So essentially what they're asking for is every single side. They want to know 1, 2, 3, plus they want to know the unknown angle. Unknown angle is pretty straightforward to solve. A triangle adds up to 180.
Yeah.
So I just got to subtract 90 and subtract 57.4, which is going to give me 90. Subtract that, it's going to be 32.6. Is it?
I had that, yeah.
All right. So 32.6. 32.6 degrees. Okay, once you have all of those, do you remember SOHCAHTOA? Vaguely?
Vaguely.
Okay. What that means is sine, your angle is theta, is equal to the opposite side. I'm just going to put O and H. Okay?
Yeah.
This is the opposite side divided by the hypotenuse. Cosine of theta is equal to the adjacent side divided by the hypotenuse, and the tangent of theta.
The only, I get, so I can easily use those, but I don't know where's theta.
Yeah, okay.
That's what
so you actually get to choose that. Depending on what you want to solve, okay? Oh, good. I was about to say, they don't have a measurement of the side. Yes, they do. 20.3?
Yeah.
Okay, you need that. Okay, so in other words, I need to solve for, we'll call it A and B, okay? Side A and side B. Side B is the hypotenuse, okay?
Yeah.
Because it's opposite of the right angle, so it's the hypotenuse. So I can use either sine or cosine. Let's figure out which one we're going to use. Let's say I want theta to be, which of the two angles would you like theta to be?
32.6.
Okay, so we're going to deal with this angle here, 32.6. So that's going to be my theta. So I would plug 32.6 into all of these thetas. Okay, essentially you could write them all out if you like, and we can figure out which one we want to use. Okay. Now since we're dealing with this angle here, we have the measurement of the adjacent side. Okay. So because I have the measurement of an adjacent side, that means I can also substitute a number in for A. Okay.
Yeah.
I can't substitute. I'm looking for H in the opposite. I have no measurements of these. So let me break this down. Let's make sense of this. Sine 32.6 is equal to O over H. Cos 32.6 is equal to A over H, which is the adjacent over hypotenuse. And tangent 32.6 is equal to opposite over adjacent. Okay. Now, once again, I said that I had, because this is the angle. Do you understand what adjacent and opposite are?
Yeah.
Okay.
Yeah.
Depends on what angle you're at.
Yeah.
So this is the adjacent side. So I'm going to continue to try to fill in variables in these.
Do you have to write out all of these?
No, you don't.
Okay.
I'm just giving you an example. You're probably bright enough that you know that, okay, sine, I can't do anything with it.
Yeah.
I don't have the measurement of the opposite or the hypotenuse. So that's already out of the picture. Cosine, 32.6. My adjacent is 20.3. So, hey, I can find the hypotenuse. And if we look at tangent, 32.6. I don't know what the opposite is, but I do know the adjacent is 20.3. So I can use cosine 32.6 equal to this, our first equation, to solve for the hypotenuse. And then I can use tangent of that to solve for the opposite.
Okay.
So I can use those two formulas to solve for our A and our B. So I'm actually going to replace H we'd call B.
Does it matter which one you use, cos or tan?
Doesn't matter what you mean.
Like which one we're going to use? Oh,
yeah. We're solving for two different sides of the triangle right now.
Oh, okay.
Do you see that? Because this angle here, okay, TOA, tan is opposite over adjacent. We have the adjacent side. I'm solving for the opposite side. Well, cosine is adjacent over hypotenuse. So I have the measure of the adjacent side, and I'm solving for the hypotenuse.
Okay.
Okay. So the reason I set up all three is just, it's kind of the fast way to set it up to solve for both. But essentially what you could have done is you could have used cos, solve for the hypotenuse, and then you could have used cos again of the other angle and done it. You can always mix it up. You get to choose what angles you want to work with.
Okay.
So it's always in reference to whatever angle you're working with. So luckily we have these two here, so we can kind of go about solving them. Do you know how to isolate for B? Let's do it. Okay, so cosine 32.6. I'm going to bring a calculator up. Okay, so we got a calculator up. Cosine of 32. This calculator is a little different. You have to type the numbers in first. Yours might be cosine 32. So we get that ridiculous number. So equals 32 is 0.842. It's equal to 0.23 over b. Okay. We'll do cosine first. We'll solve for this. Now, I need to isolate b. B's on the bottom of the fraction, so I'm going to bring it to the other side.
Okay.
And it's going to become multiplied by when I go to the other side. So it becomes b 0.42. Again, I'm trying to isolate b, so now I'm going to bring 0.842 to the other side. Yeah. Really, the fast way to do this is you just put b equals, and you bring that to the bottom.
Excuse me. Lunch?
Yeah, man. 0.842. Okay? So we can just solve for that now in the calculator. 20.3 divided by 0.842. Boom. And there is our side of the triangle. Our side B, which is 24. Let's just say 0.1.
Yeah.
Right. So our B, which is the hypotenuse, was 24.1, which makes sense. Hypotenuse is along the side of triangle, so it should be longer than 20. Let's make sure our A is right too. So let's do a tangent now. I'm just going to bring it down to the bottom. Tan 32.6A. So tangent 32.6 was equal to opposite over adjacent. And we knew the adjacent side was 20.3, right? So our opposite side, we called it A.
Mm-hmm.
But we'll leave it as O just so it makes sense for you. Tangent 32.6 tan, get a completely different number. So 0.3, whoops, 6395. It's equal to the opposite over 20.3. We're trying to isolate for O, so I got to bring 20 to the other side. It becomes multiplied by. So 20.3 multiplied by that number. Now, when you get good with the calculator, it's actually always best if keep the original answer and multiply. It'll just be a lot more accurate that way. So we take this, multiply it by 20.3, and we get 12.98 is equal to O, or as we had called it, we called it our side A, right? Yeah. Really, it's opposite. The reason I called it O is because it was opposite of our angle.
Yeah.
So this is, I already forgot that. There it is. That's it. So I've solved for every angle and every side of the triangle. We have 1, 2, 3 sides, and 1, obviously that's 90, 2, 3 angles. So it's actually a lot of work for first question in the quiz. Does that make sense?
Yeah.
Yeah?
Yeah.
Okay, so 6b. I'm just going to jump ahead to where I put a star. So I put a little star on your page.
Mm-hmm.
Hopefully you remember how to get there. Root 3 over 3 plus, and it said, even though I wrote a 1 over it, technically your paper said this. Over 6. Now the first step of what I'm going to do is I'm going to multiply this 2 inside the bracket. And when I do that, I got to change 2 into a fraction. So it's going to become 2 over 1. So our next line is the root of 3 divided by 3 plus 2 over 1 and root 3 over 6. Multiplying fractions, you just do top by top, bottom by the bottom. So we'll go root 3 divided by 3 plus. Now 2 times root 3, I don't know what it is because root 3 is some ridiculous number. I can't do that in my head. So I'm just going to leave it as 2 root 3. Kind of think of it like writing 2x.
Mm-hmm.
I don't know what root 3 is, so it's my variable, you could almost say. It's my x. 1 times 6, 6. So now I'm left with 2 fractions. Now I need the denominators to be the same. So I have a 6 and a 3. Well, I can change the 3 into a 6 if I multiply by 2. Whatever you do at the bottom of the fraction, you have to do the top to keep it equivalent. So I multiply the top and the bottom by 2. So again, 2 times root 3. We don't know, we tried it before, so we're just going to leave it as 2 times root of 3 divided by 3 times 2 was 6. Okay. Plus the exact same. Look at that. How nice. Okay. Now, since we're adding fractions with like denominators, I'm just going to put them all above one denominator, because we know the denominator of the answer is going to be 6, and I'm just going to add those. 2 root 3 plus 2 of root 3. And I want you to think of this. I'm going to say let x equal root 3, just to help us mentally a little, okay? So what I've done now is I've replaced root 3 with x. So this says 2x plus 2x. And what I can do in the end is I just substitute root 3 and back in for x, okay? So 2x plus 2x. Because we're not multiplying, all I have to do is I just add the two coefficients. So it's really 2 plus 2. What is 2 plus 2? Well, 2 plus 2 is 4x divided by 6. Okay. Now, if we go to substitute back in for that that x, remember we said x was root 3, so it's 4 times root 3 over 6. So let's write that in black over here. So the idea is all I really needed to do is I just needed to add this 2 and that 2 together. So 2 plus 2 is 4. I keep the root 3 on the outside, divided by 6. Exact same answer as I got over here. 4 root 3 over 6, 4 root 3 over 6. And she probably wants you to reduce it. So because 4 and 6 can both be divided by 2, when I divide 4 by 2, I'm just going to write it here, divided by 2. When I divide 4 by 2, I get 2 times root 3 over 3. And if that's confusing to you, think of it again back here, like when I did it back here. Let's say we were still in x form. I hadn't put the root 3 in. That's like saying, let's reduce 4x over 6. Well, I can divide both by 2, so it becomes 2x